So the next speaker is actually someone really close to me. He's a really, really cool guy and was actually my first InfoSec manager. He's also been a mentor to me, and I've watched him drop 0 days in real life, live and exclusive, which changed my life. He's the CV connoisseur himself, has spoken at an international scale on multiple occasions. He's actually the founder and the creator of Pentester Labs, and he's a Frenchman, so even cooler. The one and only Louis Nyffenegger, also known as Sniff.
Hey, can everyone hear me? Okay. Yep. So good to start. I'm going to share my screen and get started. Just need to find the right one. Yep. Okay. So code that gets you pwned, endpoint, I guess. Can everyone see it okay? The annoying part about online conference. Okay, cool. So code that gets you pwned. So basically, I do like this thing named Pentester Lab. If you don't know about it, you should probably check it out. And we have like a lot of challenges and also like some stuff around code review. And my job is basically to teach people how they can find, fix, and exploit bugs. And what I'm trying to do is find interesting patterns that will help people learn how to find new patterns. And that's where this talk is coming from, is that currently I'm reviewing a lot of source code. And the good thing is that it's relaxing me, so it's really good to, like at the moment, to be able to relax by reading source code. It's a bit weird for most people, but for me, it helps. I don't know why. And so I decided to put together like a lot of these bugs because I found them interesting, and I hope you do too. And yeah, and as Sajib says, so I run this website named Pentester Lab. Check it out. So we're going to jump straight in, and we're going to start with a bit of Golang. I wanted to be on the Discord at the same time to see like if people were finding the bug, but yeah. So let's start it. Okay, so we got this little Go function, and I think as a bug bounty hunter or as a penetration tester, you really need to look into source code to find new bugs or new patterns. And you also really need to look into upload file, because that's where you get big and cool P1 or P0 instead of finding like other bugs that may be less valuable financially, I guess. So here, this is a classic Go function to manage an HTTP request and send back a response. And we get a file from form file. Then if there is an error, we print the error and we return. If there is no error, we move to file.close, which is a way in Go to say like, once I don't need that variable, just clean it up for me. I don't want to take care of it. Just do it when you don't need it. So I don't need to know like who is still using that function, that variable. Then I'm going to create a file in /temp using ioutil temp file, and I'm going to pass the handler.filename to keep the same kind of the same name as the file that was uploaded. Then I read all the file from the HTTP request. If there is an error, I print the error and I return. Otherwise, I write the bytes into my temp file. And if everything goes well, I close my temp file and I write successfully upload this file. And that looks pretty good on paper. And there is not much that can go wrong until you look into the details. And that's a lot about what code review is looking into the details. So let's get started. If we can, yep. So first we look at the function temp file, because that sounds to be the only thing we have control over. And we can see that temp file uses 2 parameters. One is the directory where we want the file to go. So here we want to put it in /temp, so this way it's not exposed inside the web root of the server. And we also want to pass a pattern to say like, okay, this is what we want the file name to look like. And if you read carefully the documentation, you can have stars inside the pattern to say like, okay, here I want a placeholder to put like, for example, a big random number, so it's not easily guessable. And yeah, so that looks pretty safe, right? If we keep digging and we say like, okay, we want to create a file in temp, and we want the file name to be ./root/foo.star.suffix. What Golang will do is create a file in /roots foo. The big number that was used as part of the placeholder, .the suffix. So basically we can put a file anywhere we want on the file system by just uploading a file with a malicious file name. And but is interesting as well because most developers now use frameworks like a long time ago, people were using like straight PHP, and that was terrible security-wise. And now everyone moved to framework. But people writing Golang just use the standard libraries because the libraries is so good that there's no need for a framework. And the framework available mostly add overhead. But the difference here is that most frameworks, like if you look at Rails, if you look at Flask, or if you look at Rails and Express, if you put a file name in a multi-part upload with .. Rails and Express are going to clean it up for you. Flask, as in Python Flask, doesn't do it for you, but the documentation tells you like you should do that. You should really call base name on that variable because otherwise you're going to get pwned. And so that's how you end up with a file in /root, just by uploading it. So I reported that, and it got fixed recently in Golang, but still worth looking because not everyone is running the latest version of Golang, as you probably know. And it took a bit of back and forth with the development team of the Golang development team to get it fixed, but because they didn't agree it was a bad pattern, I was like, that's kind of surprising and blah, 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 but then it ended up being changed. If we look at Python 3.8.1, we do the same thing. We create in temp and we put a prefix of .. /root, and we can see that the file end up in /root again. So yeah, not a good pattern. If we look at Ruby, and I'm a big Ruby guy, we can see that if we create a file, so the arguments are backward in Ruby. So if we create a file with the pattern foo /.. root, and we create it in /temp, we can see that the file ends up in /temp. So we don't have this bug if you are testing a Ruby application. But still a good pattern, an interesting one at least. Probably hard to pinpoint when you do a black box testing, but if you do source code review, something to be aware of, definitely. Now we're going to move to the next code. So this time it's in Python Flask, I was talking about before. And we have this application that will take an argument from the URL, name URL. And if the URL starts with https://pentestlab.com, it's going to fetch the content. So you can imagine that being used to, for example, fetch images or things like that and serve that to the client directly. But since they probably got owned once, they put this anti-SSRF protection to make sure that the URL starts with https://pentestlab.com. And the problem is that starts with is a really bad way to validate a URL because https://trusted.pentestlab.com starts with trusted. Same for @pentestlab.com. This also starts with trusted. And people tend to mess that a lot. And also, so that's just going to another system directly. But if you can change vulnerabilities, you can, okay, say if it starts with trusted/jwks, you can go, for example, in another directory with .. file uploaded, a file that you uploaded before, or you can use an open redirect to link to your server if the HTTP client follows redirects. So here, what you're going to do is say, my URL starts with trusted JWKs, but when you link to your open redirect, that's going to go to your server. And just because starts with is not the right way to validate a URL. Just don't do that. And you can also link it with a header injection. So this way, here it's to fetch a JSON Web Token key, and you're going to link it to a header injection, and you're going to reflect the JWK inside the body of the response via the header injection. So pretty cool trick to be aware of. So yeah, if you're writing secure code, don't use starts with to validate URL. A really bad idea. Well, and at least if you do it, make sure there is a slash at the end of your URL. Start with can be bad, and you can do this kind of thing. But let's see here, we have a website that is written in C#, and this site is checking that the URL starts with https://, and then it's using the web client class from C# to download the URL and get that as a string, and then it's probably like show the string to the user or something like that. People tend to use this pattern to avoid the same origin policy. So they have like one endpoint that will work as a reverse proxy. So this way they can just bypass the same origin policy and serve content from other websites within the same origin. So that looks like here you're going to be forced to start your URL with https:// and then you're going to download something from the internet, right? So server-side request forgery, but not that bad until you look into the details. And it turns out you can pass this URL, https://etc passwd, and you're going to get the content of etc passwd from the local server. And then you're going to tell me like, okay, but that's a Windows behavior, right? If the directory https: doesn't exist on Linux, surely it's not going to serve the content of etc passwd. And actually, that's how. But the weirdest part is that .NET on Linux is going to mimic the bad behavior of Windows, and it's going to give you the content of etc passwd even if the https: doesn't exist as a directory on your local system. So that's something to be aware of. And that's, yeah, so then you get arbitrary file read, so you can probably get a lot more than just a server-side request forgery. You get credentials, you pop up the data, you pop the database, and you keep going. Or you get the source code, for example. Now let's move to the next one. So that's probably my favorite at the moment. So we got, again, some Golang, and we have a request and response handler. We have a file name that we get from the URL, and what we do is we clean this file name with path.clean. Then we open the file name, and if there is an error, we return file not found. Then before that, we create a defer to close the file once we're done with it. And then we copy the content of the file to the response. So that's an easy way to serve content in Golang. That looks pretty clean because I guess we have path.clean. So let's dig into the path.clean documentation. So if we look at the examples, we can see that path.clean, and that's straight from the Golang documentation. And we can run that because the Golang documentation is so good. And we can see that if we run that, we got a/she become a/she, then a/a/she, so somewhere around here, give us a/she. So that looks like, okay, this is exactly what you want as a developer to secure things, because you heard about your security team telling you like, okay, oh, you need to remove .. And path.clean does exactly that. It removes .. unless the string doesn't start with a slash. And then path.clean is just a way to clean the data and make sure you got the proper path. It's not a way to remove .. and directory traversal, just to make sure that the path you're passing is clean, not that it's going to be between quotes secure or usable in a secure way. So if the path starts with .. it's going to keep the same meaning, so it's going to stay .. That's only when you can canonicalize the path that it's going to happen, if that doesn't change the meaning of the path on the file system. So that's pretty surprising. Last time I did this talk, someone raised it on Twitter, and what's his name? Filippo is trying to get it fixed, and that's currently where this is happening. Thankfully, with the Golang development team, you probably got a few months before they decide to fix it, because that's not as bad as they think it is. And for now, I think they're still waiting on updating the documentation. So something to be aware again, because if you go here and quickly like read that code, you're like, okay, path.clean probably cleans things, right? So it's probably safe. They thought about cleaning, but as soon as you look into the details, you can find pretty cool bugs. And yeah, so even if something looks like it's doing what it needs to do, you should always check. And at the same time, and go in depth to make sure that it's really, really what you think it does and what the limits of the functions are. So now let's look. So that's a pretty common one. You have an event listener to listen to post message. And since the first thing you see when you're creating an event listener and you look at the Mozilla documentation is you need to check the origin. So what do? You check the origin. So here we're going to check that the origin matches .pentesterlab.com and $ to do the end of the regular expression. Yeah, and you should look at Event Handler if you're doing bug bounty. I think someone made 20K on Facebook a few days ago. So yeah, so we're going to do something only if the origin is safe. The problem is that you got this good, amazing relationship between regular expression and host name. That in regular expression, a dot is a wildcard. So you can replace it with anything. Where in host names, in DNS, the dot means a separator. So here, if we match .pentesterlab.com $, we're going to be able to match www.pentesterlab.com, but also www.pentesterlab.com or www.pentesterlab.com, because the dot is a wildcard. So any character will work here. So that's a really easy way to bypass this check. And the issue here is that the developer didn't think about escaping the dot in the regular expression. So instead of being literal dots, they are actually wildcards. And again, attention to details. So now we're going to move to another one. So we got here a JavaScript application that's going to fetch content from a domain. And so we call fetch, and we have a list of domains that are allowed. And we check that the domain is in the list that is allowed. The list that is allowed is example.org, gmail.com, google.com. The only thing that we do is we call to uppercase on the domain. And then we fetch the content and we send the content back to the user. So that looks, again, pretty safe. You just like eyeball the code. You're like, okay, they're checking in a list in an array. So it's pretty hard to find something that will break this kind of checks. But thankfully, we have the to uppercase. And all this issue, looking at this kind of issue came after I read that blog post around someone who found a bug in GitHub with a Unicode.si. After I knew about Unicode bugs like that, but after this one, I was like, oh, I should probably dig deeper because I think that's interesting. And I think we can find a lot of bugs like that. And actually, there's something interesting about the blog post as well. I will come back to that later. But basically, .i, if you call to uppercase on it, will become a uppercase I. And gmail.com with a .i instead of I, to uppercase, we become gmail.com. And so this way, by registering gmail.com with a .i, you can bypass this check. So the thing I wanted to say about this blog post is that there was a difference between the way it was reported by the researcher and by GitHub, because actually the same thing happened at the database layer. So even if the code doesn't do to uppercase, since string comparison in a lot of databases are not case sensitive, if you're using varchar, the same kind of bug will happen depending on the char set of the database. Something really interesting to look into if you have a bit of time. So yeah, and to get back to this blog post, that was really, really good. You had like a lot of characters that become, when you call to uppercase or to lowercase, change between what they mean. So you should probably check it out, and that's probably a good way to find bugs. But yeah, so the thing that is the most crazy about it is that that's not some kind of like weird JavaScript quirk. That's not some kind of weird Ruby thing. That's just actually the way Unicode should work. And the even craziest thing is that depending on your system locals, it's going to change. So if you are like between quote normal and you have like a .si, it's going to become a uppercase I. If you, however, using Turkish locals, the lowercase I will become uppercase I with a dot. And the lowercase I with no dot will become uppercase I with no dot. And then you have all this transformation and similarity between like two characters can become the same in Unicode, but that's something definitely worth looking into, and that's just how it should work. So if a language doesn't support that, it's because the language is behind the Unicode implementation guideline, not because it's safer. And that's very surprising for developers because they never heard of that before. Oh, I had some challenges. If people want to play, I forgot to start them up, but I'm going to start them after the talk. So if you want to play with Unicode challenges, go to these two URL. Yeah. So we talked about regular expression. We talked about Unicode. What if we mix the two? What if we do Unicode and regular expression? So if we start looking at Python 3.8.1 and we do re.compile I, and we want to see if .i matches I, we don't get any result. It doesn't match. Then we add ignore case to say match, but ignore the case. So lowercase I and uppercase I should match. And by doing that, we can see that .i matches I if we ignore the case. So that's in Python. And same thing for the Kelvin sign at the bottom, the K. And same thing for the long Latin S. That will match uppercase S if we ignore the case. And Kelvin sign will match K if we, sorry if it's over your head a bit, Galactic Omelette, I like your nickname. Very cool. So yeah, and same for Kelvin sign. Then if we move to Ruby, Ruby will never match a .i if we ignore the case. So .i will not match I if we ignore the case. And same for uppercase I's. Even if .i, when we call upcase, will become a uppercase I. So that's weird. Even probably can help you like fingerprint how a filter is done. Is it using a regular expression? Are they using ignore case? Are they not using ignore case? Are they uppercasing the data? So even if the I doesn't, yeah, I can put the URL, so I should focus on that. So the weird thing is that even if the .i doesn't match I, with ignore case, the Kelvin sign will match K if we ignore the case. So we have different behavior for different characters in Ruby. And same for the long Latin S. So 0 means that it's matching. Nil means it's not matching. So if we ignore the case, the long Latin S, so this weird F on the left, matches S. So different behavior depending on the characters. Then if we move back to Golang, and in Golang, when you do matching, you use this bracket question mark I. And if we say, does .i matches I, if we ignore case, then it's false. But the same behavior happened for K and long Latin S, those two matches. So again, weird behavior. In C#, it's only, so the long Latin S doesn't match, but and the .si doesn't match, but K matches the Kelvin sign if we ignore the case. So again, that was tested on linux.net. And yeah, and even if we use ends with, and we're using all the way Microsoft has to compare strings. And a friend of mine used to say that's probably because they had so many Unicode bugs in Windows that they had all this way to compare strings. So if we're using invariant culturing, in no case, it's not going to match. If we don't put a second argument, it's not going to match. If we put ordinal ignore case, so the classic way to ignore case, it's going to match. And current culture ignore case, it's going to not match as well. So we have all this way to match things in C#, and you're going to have different behavior for that. In Java, if we do equals in no case, all of these are going to match. But as soon as we move to regular expression, it's not going to match anymore. So .si doesn't match I, long Latin long Latin S doesn't match S, and the Kelvin sign doesn't match K if we use ignore cases. So again, maybe a good way to fingerprint, thanks DNZ, maybe a good way to fingerprint your application. So like, okay, with these characters, I can tell that it's not matching. So maybe it's a Java app or a C# app, or it's matching. So maybe it's Ruby. And why is it important? Imagine you have an application that it's going to check that the domain matches something, or an email address ends with something. Like, for example, if your email address ends with pentesterlab.com, you are admin on pentesterlab.com, which is a terrible way to check. But that's often what people are doing because it's really, really easy. Now, what you can do is just register an email with pentesterlab.com is a weird one because I don't have a SK. Oh, I got a S. So yeah, you can register a domain with the Latin S and say, okay, I'm going to try to register on pentesterlab.com with this Unicode domain and see if I can become admin on pentesterlab.com. And you can do the same thing for server-side request forgery, and you can do the same thing for cores as well. Although it's likely for cores that your browser will not send the character as it is. It's going to encode it as Punicode here. So unless you have something that really codes it on the server side before giving it to your check, it may not happen. And for the Kelvin sign is less likely because Kelvin sign, the problem you're going to have with it is that you need to register a domain with an uppercase letter, and that's not going to go well. So yeah, so that's why it's important. So yeah, that's about it for me. So to conclude that, computers are hard, devil is in the details, don't make assumptions. I think what I wanted to show is that you really have to look in depth to find this kind of bug, and you can just eyeball code. Oh, so first, I think you should read code as a penetration tester or as a bounty hunter on a regular basis. Try to read a bit of code every day, because that's how you're going to get, I think, to the next level. Doing black box testing after a while only gets you so far. You need then to like try to read source code to see like, okay, how people are creating applications. What mistakes do they make when they create application? And once you do that, you're going to start finding patterns that you can apply when you're doing bug bounty. And the thing is that these patterns are going to be not as well known as the one that everyone is looking for, and that's how you're going to be successful. And because hundreds of people will probably look at the path.clean and say like, okay, that's fine. Path.clean is fine, all right? Like, what can go wrong? And then if you like spend, I don't know, it probably took me like 20 minutes to like create a Docker container with Go, write path.clean. Actually, I didn't even do that. It took me 5 minutes. I said like, I went to the Golang documentation, and you can execute the code you're passing. So what you can do is just like start playing with the value in the documentation and click run code. And that's when you can detect like, okay, this is weird. This is a good pattern. I need to look into more depth. And then you keep it. And if you do that, I don't know, once a week, twice, 5 times a week, 7 times a week, you're going to keep accumulating all these weird patterns, all these bugs that no one else has or no one thought about, just because you're reading code that no one else is reading. And yeah, that's how you find good bugs, and that's how you make money if you're doing bug bounty. So yeah, I think do that. And yeah, don't make any assumption. Like, that's the worst thing you can do when you're testing is, it's not because something looks fine, but that is fine. Maybe there are some weird corner cases that no one thought about. And yeah, just spend a bit more time than everyone else and you're going to be successful. And that's about it for me. Thanks for your time. And if you have any question, I can see some on Discord. If you can read them.
Yeah. Louis, just wanted to say that was a really, really good presentation. Great job, mate. Also, love your background. It's hilarious.
Yeah.
Yeah, so I actually wanted to quickly ask a few questions that we've been gathering. How do you actually stay up to date with all the different patterns that you're seeing? Because you showed patterns in different languages, like Ruby and Go act completely different in different ways. How do you actually go and keep track of all of that?
So I do what I call entomology. So I'm basically a bug collector. So what I do is you need to follow mailing list of big projects, or Apache mailing list for all the Apache project, Ruby on Rails because they have really cool bugs. And I also follow like bug bounty disclosures. So to see like, okay, what is happening? And so following is one thing, but then you need to be active. Is like reading something on Twitter only gets you so far. Like, So what you need to do is, okay, I've saw this bug in Ruby on Rails. Let's look at a diff of the source code. Let's look at what was the bug and how did we fix it. And then you can say like, okay, this was in Ruby on Rails. That's really interesting. What happens if I take the same pattern and move it to Golang? What does a vulnerable code base will look like? And then you can look for this pattern in all the Golang project you know about. And then you have done that for Golang. So you move to C#. And then you're like, okay, I know that, I don't know, this website, they are a big Ruby shop. So maybe I'm going to test my new Ruby pattern against all their endpoints, and I'm going to get lucky. And I think it's just like, yeah, Vulnemon, yeah, like Pokemon for vulnerability, like going to collect them all. And having all these patterns and having quick way to test, like if you, in 2020, if you're not using Docker almost every day, you're doing something wrong. Like you should always like, I got aliases in 2 minutes. I got like a Docker container with any code base I want. I say like, okay, I'm going to test some Golang today. I'm going to test some Ruby today. And yeah, and keep them and like keep learning from what other people are doing and see like, okay, this pattern is interesting. I have it now in 5 languages or 4 languages. What can I extend it? Can I find something more about it? Is there something that no one else realized that is even more interesting? And you keep building up. Like, so instead of reading like a lot of articles and like flying over all this content, just from time to time, stop flying and just drop and go deep, like go really deep, get the source code, get a diff, get a patch, try to build your own little lab to get it working, to see how it works, try to debug the bug and keep going. Yeah. For the Apache group, I see the question in Discord. For the Apache, I'm using just Apache News. They give like all the CVEs and all the new version of every project. So you get like probably 2 or 3 mails every day, 3 emails, but yeah. And yeah, like, yeah, dig deeper. Like that's, yeah, probably my biggest advice, I guess.
Sweet. So do you actually have a specific methodology you like to follow when you're performing source code analysis for web app hacking? And does that actually differ from things like when you're testing a thick client and things like that?
Yeah, so I think when you're doing like pen testing, you're probably gonna have to set up everything, and then you start reading and or seeing what's going, and it's like kind of adventure where you pick like what direction you're going into. Where when you do code review, I try to mostly I'm not anymore. I'm not paid to review one code base at the moment anymore. So what I do is I review per functionalities. So that's a really good thing you can do with code review is instead of reviewing a forgot password reset in one project, that's really hard. You need to think about everything a password reset needs to do and needs to do properly, right? What is really easy, it's to review reset password across 5 projects. And then you compare them and you say like, oh, that's how they're doing it. That's how they're doing it. That's how they're doing it. Why are this guy not doing this check that everyone else is doing? And bang, you got a bug. And you just compare things instead of just like trying to be smart and think about everything. You just like basically like leverage other people's work and say like, okay, all of these projects are doing that. This one is not doing like the other one. Why is that? And what's the impact of that? And often you get bugs. Like it's free real estate. And yeah.
Yeah, I think that's actually quite an underrated thing. I don't think many people actually do that they'll get multiple projects together and then actually diff them to see the differences.
And
So
same thing for, sorry.
sorry, no, continue.
Same thing for when you're doing bug bounty. It's probably worth looking at, especially when you're starting, instead of looking at one password reset for one project, get password reset for 5 websites and compare them and see what's happening and why it's different and what the impact of these differences.
Now changing the scope a little bit, what kind of lessons have you learned actually going into the full entrepreneur space? Because you used to be a very, very strong pen tester. how was that transition? What did you learn going into the Pentester Labs business?
A lot. I'm still learning a lot. So many things. I learned to do taxes. I learned to do invoices. I learned to do marketing. Obviously, you don't want to learn. Now, well, I think what I learned is that a lot of people tend to be afraid of like entrepreneurship, thinking like, oh, that is so complex. That is so hard. But trust me, like if you can reverse an Android app or find a bug on like in a bug bounty, you're probably likely able to create an invoice. And even if like you mess it up, people are going to help you. My first invoices, I messed it up, and people help me. They say like, "Oh, we probably need this information, this information, this information." It's like if you can reverse stuff, if you can find cool bugs, you probably can create a business. That's the easy part, especially starting. Keeping it up and keeping going for a long time is probably the hardest part. But yeah, starting and all the businesses thing is probably the easier part, I'd say. Like invoicing and stuff. I used to be afraid of doing invoices. It's really easy, right? It's even easier than writing a pen test report.